Hello, welcome my dear students. Today we will do polynomials of NCERT class 10 mathematics. So in this video we will be discussing the degree of the polynomial, types of polynomial, linear polynomial, quadratic polynomial and cubic polynomial, and geometric meaning of zeros of the polynomial. Okay, degree of polynomial. If px is a polynomial in variable x, then highest power of the x is called degree of the polynomial. For example, any polynomial 5x plus 2 is a linear polynomial, so its degree is equals to the highest power of the variable is 1, so its degree is 1. So y square plus 3y plus 5, so its degree is equal to the highest power of the variable involved. So y is the variable, so highest power of the variable is 2, so degree of the polynomial is 2. Okay, so five x cube minus 3x square plus 7x plus 3, so its degree is since the highest power of the variable is 3, so its degree is 3. So I think degree of the polynomial is clear. Okay, now linear polynomial. So linear polynomial is a polynomial of degree 1. So a polynomial of degree 1 is called a linear polynomial. So for example, 2x minus 3 is a linear polynomial. Root 3x plus 5 is a linear polynomial. Okay, 2y plus 7 is a linear polynomial. Now quadratic polynomial. So quadratic polynomial is a polynomial of degree 2. That is, a polynomial of degree 2 is called a quadratic polynomial. The name quadratic has been derived from the word quadrate, so which means square. So quadrate means square. So quadratic polynomial is a polynomial of degree 2. So for example, I will show you 2x square plus 3x plus 5 is a quadratic polynomial, like y square plus 3y minus 7 is a quadratic polynomial. Now cubic polynomial. A polynomial with degree 3 is called a cubic polynomial. So for example, I will show you some example. 2 minus x cube is a cubic polynomial. So 3x cube plus 7x minus 5 is a cubic polynomial, right? Just y cube is also a polynomial with degree 3, so it is a cubic polynomial. Okay, next concept is zero of a polynomial. So generally a real number k is said to be a zero of polynomial px if pk is equals to 0. For example, I show you an example. So for polynomial px is equal to 2x plus 3, so for this polynomial let us find the 0 of this polynomial. So if k is 0 of the polynomial px, then p of k will be equal to 0. Okay, so your polynomial is px, so here pk means 2k plus 3 is equal to 0. So from here what you get, so 2 into k, 2k is equal to minus 3, so k is equal to minus 3 by 2. So this is the 0 of this polynomial. So if you put this value here, so this will reduce to 0. In general, so if k is a 0 of the polynomial px is equals to ax plus b, then p of k is equal to ak plus p equals to 0. So this implies k is equals to minus b by a. So the 0 of the linear polynomial ax plus b is minus b by a. So that is equals to minus of constant term, since b is the constant term, divided by coefficient of x. Okay, so this is the relationship between 0 and the coefficient. Now let us discuss geometrical meaning of the zeros of a polynomial. So you know that a real number k is a zero of polynomial px if pk is equals to 0. But why are the zeros of polynomial so important? Let us see. So with an example, let us take a polynomial, linear polynomial, p of x is equal to 2x plus 3. So it is in the form ax plus b, so its 0 will be equals to minus b by a, you know. So its 0 is equals to minus 3 by 2. So this is the 0, we know. So let us see the geometrical meaning of this 0. Okay, let us represent this polynomial by y is equal to 2x plus 3. So I have taken one more variable to draw its graph in two-dimensional plane. So let us make a solution box here. Okay, x and y. Okay, so when the value of x, if we put 0, then what you get for y? Y is equal to 2 into 0 is 0 plus 3, so 0 plus 3 is 3. Okay, so when the value of x is 1, so 2 1 is 2 plus 3 is 5, so value of y is 5. Okay, let us draw a graph. So this I have made the Cartesian plane. Now we can plot the graph from the table. Okay, so first point is 0 comma 3, so x coordinate is 0 and y coordinate is 3, so 0 comma 3, x is 0 and y is 3, so point is here 0 comma 3. Okay, so next point is 1 comma 5, x coordinate is 1 and y is 5. Okay, so 1 comma 5. Okay, so now we have to draw the line through this both the points. Okay, so this is the graph of the equation, this one. So y is equal to 2x plus 3. Okay, so it passes through this point. So this point is, the x coordinate is here 1.5, or we can say 3 by 2, minus 3 by 2, because this is negative side of the origin. Okay, and the y coordinate is on whole x-axis, the y coordinate is 0. Okay, so this is the coordinate of the point where this line is crossing the x-axis. Okay, and we know the 0 of the polynomial is also minus 3 by 2. So the 0 of the polynomial and the x coordinate of the graph is same. So this is very interesting, right? So x coordinate of the point where the graph of the equation crosses x-axis is same as the 0 of the polynomial. So the geometrical representation of the 0 of the polynomial is the point or the x coordinate where it crosses the x-axis is the 0 of the polynomial. Okay, now let us see exercise 2.1. The question is the graphs of y is equal to px are given in the figure 2.10 below. The sum polynomials px for some polynomial px. So find the number of zeros of px in each case. So first graph is this one. So we have to find the number of zeros. Okay, so this graph, so this is not touching the x-axis at any point, so the number of zeros is 0. So number of zeros is equal to 0 since it is not crossing the x-axis. So 0 of the polynomial is the x coordinate of the point where it crosses the x-axis, and if it is not crossing the x-axis at any point, then it is no 0, right? So in this figure, so number of zeros, so how many times it is crossing the x-axis? It is crossing the x-axis at once, so number of 0 is 1. Okay, in this case it is crossing how many times? 1 2 3, so 3 times it is crossing the x-axis, so number of zeros is equal to 3. So and so on, you can do the following questions also. Okay, thank you very much. Hope this video helps you in doing this exercise and also understanding the basic concept of polynomials. Dear students, please subscribe the channels and press the bell icon so that you can get my video at the earliest.